Hello class. In this video, we cover section 3.2, compound statements and connectives. Simple statement expresses one idea that is either true or false, but not both. We use lowercase letter p or q or r to represent a simple statement. Sometimes we encounter statements including more than one simple statements. And those simple statements are connected with logical connectives. And that kind of statement is called a compound statement. A compound statement is two or more simple statements combined with a connective. And today our focus is to understand those important logical connectives. We are going to cover 4 different connectives. They are conjunction, disjunction, if-then, and if and only if. The first one, conjunction. Conjunction. So conjunction also is called and. It is a upside down V. The notation for conjunction is an upside down V. And you can understand that or connect that, remember that with the conjunction in set theory. This notation means and, right? Is a upside down U, is a conjunction. It means and in set theory. But in the logical connective representing and is upside down V, upside down V. When we have two component statements, let's say P and Q, and we want to express P and Q, or P but Q, or P yet Q, or P numberless Q, then we use P and Q, the conjunction, to represent those statements, compound statements, symbolically. That's the basic definition of conjunction, the upside down V, upside down V. We have many tables in these sections. I recommend you pause the video and read them through. Those informations in the table very important. Let's look at this example. P and Q are given. P is the statement that I'm leaving. Q is the statement that you're staying. We are going to use the symbols, the connective symbols, to write the compound statements. Okay, let's see this one. I'm leaving and you are staying. So the connective here is and, right? So we are going to have a conjunction, P and Q. Give me a little time to find the notation and. This symbol. See if I can easily find the notation. It's upside down V. Let me try copy paste. Copy paste here. Nope, it doesn't work. Copy paste this one. P and Q, P and Q, right? I'm leaving and you are staying. So we use a conjunction, connect P and Q. I'm leaving and you are staying. So P and Q, P and Q. You're staying and I'm not leaving. I'm going to handwrite those results. You're staying and I'm not leaving. You're staying, so it's a Q. And I'm not leaving. I'm leaving is P. I'm not leaving is not P. It's a negation of P. So the symbolic form of this compound statement is Q and not P. With here, you can put a parenthesis, or without a parenthesis, they're gonna mean the same thing. Technically, we do not need a parenthesis. The second connective we learn is or. You can understand or remember that with the union notation in set theory. This notation means or in set theory, right? And a right side up V also means or as logical connective. Common statements including the connective or are called disjunctions. Disjunctions. Or here is inclusive or, same with what we have discussed in set theory. For example, P is the statement that I study. Q is the statement that I pass the course. We are going to write the following compound statements in symbolic form. This common statement states I study or I pass the course. I study or I pass the course. So P or Q. Very straightforward, right? The structure of the compound statement is very straightforward. The second statement, I study or I do not pass the course. I study P. Or I do not pass the course, not Q. P or not Q. I study or I do not pass the course. The third connective we are going to learn is the symbol implies. We also call that if-then statements. Symbol, I call this symbol implies. If we have two simple statements and we see the implies notation in between, and that gives us a conditional statement. And the simple statement in front of the symbol is the antecedent, and the statement right after the symbol is the consequent. Yeah. So that as you can see, antecedent is the statement before the notation. Consequent is the statement right after the notation. In words, we can describe a conditional statement. If P, then Q, in many different ways. This table gives those expressions. P implies Q. Sometimes I say P implies Q. Can be stated as if P then Q. Also can be stated as Q if P. Another way to express that is P is sufficient for Q. You want to remember this one, very important. What is sufficient? What is necessary? Here, very important. Q is necessary for P. P only if Q. Only if Q, P. All those sentences, English sentences, describe the same statements represented by this symbolic form. And in this table, we also have examples. I recommend you spend time to read it. Conditional statements in English often omit the word then and simply use a comma. When then is included, the comma can be included or omitted. Here are some examples. If a person is a father, comma, then that person is a male. That statement, English statement, represents a conditional statement, right? Or we can omit the comma, and the sentence still represents a conditional statement. If a person is a father, then that person is a male. Sometimes we do not have then, the word then, but we have a comma, and that structure, same thing, represents a conditional. If a person is a father, comma, that person is a male. It means the same thing. Very important thing is you know in a conditional which part is the antecedent, which part is the consequent. Let's look at this example. Let the P and the Q represent the following simple statements. P is the statement that this is an alligator. Q is the statement that this is a reptile. Write the compound statements in symbolic form. If this is a reptile, then this is an alligator. This is conditional, right? Yeah. The one follow if is going to be the antecedent. This is a reptile, Q. The sentence or statement follow then would be the consequent, P. This is an alligator. So Q implies P. If this is a reptile, then this is an alligator. Being a reptile is necessary for being an alligator. The one that is necessary is going to be the consequent. So being a reptile is a consequent. Yeah, this is a different statement, all right? We just finished the first statement. The second statement in word is being a reptile is necessary for being an alligator. So the one that is necessary is the consequent. This is a reptile, so Q is going to be the consequent. And P, being an alligator, would be the antecedent. So Q is necessary for P. Is the same with if P then Q. Being a reptile, Q is necessary for being an alligator. So P implies Q. The last symbol, connective symbol we are going to learn is if and only if. Is a double direction, a double arrowheads, if and only if. One thing I want to point out is P, if and only if, Q actually means P implies Q. At the same time, Q implies P. All right, so both directions works. Yeah. If we have P implies Q and Q also implies P, then together we have P if and only if Q. Both directions. Sometimes when we say P if and only if Q, as P and Q are equivalent. Yeah, when you see if and only if statement, you are looking at a biconditional statement. Yeah, please spend time to read this table. Let's answer the example here. Let the P and Q represent the following simple statements. P is the statement that the campus is closed. Q is the statement that it is Sunday. Write the compound statements in symbolic form. We have 1, 2, 3 common statements. Okay, the first one, the campus is closed if and only if it is Sunday. Okay, the campus is closed, P, if and only if it is Sunday, Q. Number 2, the campus is not closed. So not P. If and only if it is not Sunday, not Q. Number 3, the table below summarizes, okay, so this is not one part of the example. So the table below summarizes the connectives used to form compound statements. Technically, the negation doesn't give us a compound statement, but for convenience, we include the negation in the table and look at it with other connectives. That's all we need to know about logic connectives: negation, conjunction, disjunction, conditional, and biconditional. The last thing about those logical connectives is their dominance. Sometimes we have a compound statement that includes more than one symbolic logic connectives. Then how do we understand the structure of the compound statements? We need to understand the dominance of connectives. And you need to understand this part. Very important. The biconditional has the strongest dominance. Follow with conditional. Conjunction and disjunction have the same level of dominance. They are weaker than conditional, but stronger than negation. Negation has the weakest dominance. How do we apply the dominance of connectives? So if you see, for example, if you see this statement has conditional, has conjunction, has negation, right? Yeah, it has conditional, it has a conjunction, it has negation. Now, how do you understand the structure? We have to understand the structure correctly in order to understand what the statement is stating, right? And based on the dominance of connectives, we know the structure of this compound statement is conditional. Because the conditional has the biggest dominance, strongest dominance. So whatever to the left or in front of the conditional symbol is the antecedent, and whatever to the right of the symbol is the consequent. So we can translate this common statement as P, if P, then Q and not R. Yeah. Sometimes we put a parentheses to frame the consequent together to make the structure even clearer. But without the parentheses, technically, it is still correct. But the last one in this table, this is not clear. Because conjunction and disjunction have the same level of dominance. Unless you put parentheses, we would not know the meaning, the real meaning of the compound statement. Yeah, I recommend you spend time to look at the structure of those compound statements and understand how does the dominance of connectives work in the structure of the compound statement. Let's look at the examples. P represents the statement Romeo loves Julia. Q represents the statement Julia loves Romeo. We are going to write each symbolic statement in words. Okay, so we have a parenthesis, right? Yeah, if we have a parenthesis, that means the negation is negating the whole thing in the parenthesis. So the biggest structure of this statement, common statement, is negation. We can say it is not true that. Yeah, that's one way to negate a statement. Yeah, we are negating the statement. It is not true that. And look at the statement in the parentheses, P or Q. It is not true that Romeo loves Julia, or it's disjunction, right? Julia loves Romeo. And that's how do we describe the common statement represented by this symbolic notation in words in English. It's not true that Romeo loves Julia or Julia loves Romeo. Next, not Q and P. Not Q and P. And P is Romeo. Let me copy this part and I can see. Read better. Not Q and P. So Julia does not love Romeo. This negation only negates Q. All right? Yeah, not Q together is a component of this conjunction. All right? Yeah, we have two pieces in this conjunction. Not Q is one piece. P is another piece. Not Q. Q is Julia loves Romeo. Then not Q would be Julia does not love Romeo. And or you can say but, right? Yeah, same thing. And or but is better in this situation. Yeah, Julia does not love Romeo, but Romeo loved Julia. Next, the negation here only negates P, right? Yeah, so not P is the first piece, Q is the second piece, and the two pieces take a disjunction. So P is Romeo loves Julia. Negation of that is Romeo does not love Juliet, or Juliet loves Romeo. Romeo does not love Julia, or Julia loves Romeo. So that's the structure of the statement. Next, PQR is given. We are going to write each compound statement in symbolic form. P is the temperature outside is freezing. Q, the heater is working. R represents the statement that the house is cold. Let's read this sentence. If the temperature outside is freezing, then the heater is working or the house is not cold. And as you can see, we have if then, so that is conditional, right? It's conditional. And we also have or here, and that is a disjunction. Which one has higher level of dominance? Conditional has higher level of dominance. So this is a conditional, all right? Conditional. If the temperature outside is freezing, so if P, then, follow then, we have the consequent. The consequent itself is a compound statement, is a disjunction, Heater is working, Q, or, this is or. House is not cold, so not R. All right? Yeah. You can put a parenthesis here to make it clear, even clearer. Or without a parenthesis, it is still correct. We should not have any confusion because of the dominance of connectives. If P, if the temperature outside is freezing, then we have disjunction as a consequent. The heater is working, Q, or the house is not cold. So not R. And the next sentence, the house is cold if and only if. So we see a double biconditional, right? Yeah, biconditional, if and only if. The temperature outside is freezing and, one piece, two pieces. We need the two pieces to make a biconditional. The second piece obviously is a conjunction here, conjunction and. And the first piece, the house is cold, so R. If and only if the temperature outside is freezing and the heater isn't working, so not Q. Same with earlier, if you want to put a parenthesis here, then you make the structure of the compound statement even clearer, more obvious. But without the parenthesis, should not have any confusion about the structure, about the statement, the meaning of the compound statement. Let me double check. R, the house is cold. R, if and only if. temperature outside is freezing, P, and the heater isn't working, not Q. Yeah. The last example here, we have three components, three simple statements are given. We are going to translate those statements, common statements given in the symbolic form to the English, all right? So that's the question. P is, the temperature is above 85 degrees. So this is a conditional. This is conditional. If P and Q, if the temperature is above 85 degrees, and we finished studying, then R, we go to the beach, right? So that's the first one. Second one. The second one is a conditional, right? Conditional as well, yeah. So to make it clear, I'm going to place a parenthesis here to frame the consequent. The antecedent is not R. So if not R, R is we go to the beach. Not R would be we do not go to the beach. If we do not go to the beach, then the consequent is a disjunction, not P or not Q. The temperature isn't above 85 degrees. The temperature isn't above 85 degrees, or with a disjunction, not Q. We did not finish studying. We did not finish studying. Okay, yeah. So if follow with the antecedent, which is not R, then follow then we have the consequent. The consequent is a disjunction. Temperature isn't above, not hot enough, or we didn't finish the job. We didn't finish the study. All right, so that's the last one. This section might be a little bit challenging, especially the dominance of connectives. So if you encounter any challenging questions in MATLAB Math, feel free to email me, okay? I'll see you next time. Bye.